All right, moving on to our last operation, multiplying matrices. Now, multiplying matrices, a little different than adding and subtracting matrices. Say we had a m by n matrix, m rows, n columns. We'll call that matrix A. And we have another matrix B, the entries of B sub ij, that is the size of n rows and p columns. So it's an m by p matrix. Well, the product AB is going to be a m by p matrix. So here's the thing. With multiplying matrices, right, it doesn't say the orders have to be the same. Right? When they add and subtract, they're going to be the same size. All right, what has to be the same is the columns, and we'll circle it here. The columns from our first matrix must equal the rows from our second matrix. So columns, we make that note. Columns from first matrix, right, must equal the rows from our second matrix in order to multiply. If they're different, the product is undefined. Now, the other two entries that we did not compare, the rows from our first matrix and the columns from our second matrix, M and P, form the size or the order of your product AB. All right, so what we're going to be doing in multiplying matrices is we're going to end up multiplying rows by columns. All right, so to form this matrix, we're going to take a row and multiply it with a column. So, for example, we wanted to find the ith row and jth column entry of product AB. We would do this by multiplying the entries in the ith row from your first matrix with the entries in the jth column in your second matrix. So, for example, row 1, column 2, you would take row 1 entries from matrix A and multiply with column 2 entries from matrix B. All right, so again, a little different. So let's go through some examples. Let's find, for example, let's start with this product here. I've got three matrices given, A, B, and C. Let's find AB. All right, so what would product AB equal? All right, so let's go ahead and write down, let's show our work. So A times B, or AB, is equal to, now we have a 2 by 2 matrix. 1 and 5 for row 1 entries, 2 and 0 for row 2 entries. Multiplying with matrix B, now matrix B is a 2 by 3 matrix. Row 1 entries are -2, 0, and 4. Row 2 entries are 1, -1, and 3. So I want you to notice the size of these two matrices. We're right beneath them. Let's always write in our order. So 2 by 2 with 2 by 3. Well, here's what's the same. This is important. These must be equal. If they're equal, we can move on and find the product. All right, so we compare the other two. So the product of our matrix is going to be a 2 by 3 order. So when we build our matrix over here, we're going to need a matrix big enough for 2 rows in it and 3 columns. So we're going to need a 2 by 3 product. All right. So let's go ahead and work on finding those entries. So I'm going to start with the first entry here. I'm going to write a little note above it. So I'm going to find row 1, column 1. So I'm going to multiply row 1 with column 1. So my row 1 entries, 1 and 5, I'm going to multiply with column 1, -2 and 1. So let's go ahead and begin that product. So the first entry in the row, which is a 1, times the first entry in the column, which is a -2. 1 times -2, row 1, column 1. So the corresponding entries, first entry in the row, first entry in the column. And as we move, we add. So as we move through the row, we're going to add up the result of these products. And now we've got to multiply 5 with 1. So plus 5 times 1. So there's row 1, column 1 entries multiplied together. Right, and we'll simplify in the next step. All right, let's go to our next entry. So now what we're going to do, if we want to find row 1, column 2, right, we're going to multiply 1 and 5, right, with column 2, 0, and negative 1. So we'll write that above it. So row 1, column 2 entry. We've got to multiply row 1 with column 2. So the first entries, 1 and 0. So we got a 1 times 0 plus we have a 5 times a negative 1. All right, and those are the second last entries in the row and column. And that takes care of row 1, column 2. We'll do the arithmetic in the next step. All right, let's move on to row 1, column 3. So now we're going to multiply row 1 with column 3. So first entry in the row, which is a 1, multiply with the first entry in the column, which is a 4, plus first entry in the row, which is a 5, and second last entry in the column is a 3. And that puts us at the end of our matrix. Remember, this is a 2 by 3 product. So let's go ahead and draw in our bracket, and that's the end of row 1. So if you want, right beneath it, let's go ahead and write down the result of those entries. So what is negative? We got negative 2, right, plus 5. And here we have 0 plus negative 5. Here we have 4 plus 15. So in our sum, negative 2 plus 5, we got 3. 0 plus negative 5 is negative 5. 4 plus 15, 19. So 3, negative 5, and 19 are the entries for row 1 in our product matrix, AB. So again, finding our product, we've done the algebra behind row 1. Well, let's do the same thing to get our row 2 entries. So now, moving on to row 2, all right, now we got to take what? We're going to have to take row 2 numbers, 2 and 0, right, and multiply with column 1 in order to find row 2, column 1 entry. So 2 times first entries, we got 2 times negative 2 plus 0 times 1. All right. So again, they're the corresponding entries. Let's move on. We'll do the arithmetic in the next step. Let's move on to row 2, column 2. So now we've got to multiply row 2 numbers from our first matrix with column 2 numbers in our second matrix. So the 2 and the 0 with the 0 over here and the negative 1. So first entries, we got a 2 times 0 plus 0 times negative 1. Second entries in each, right? And then moving on, we go to our last entry, which would be row 2, column 3. So we got to multiply row 2 with column 3. So we're going to take the 2 and 0 and multiply with the 4 and 3. So 2 times 4 plus 0 times 3. All right, so let's write down our results of those. So down here we'll do the arithmetic. So here we got what? 2 times negative 2, that's negative 4, plus 0. Here we got 2 times 0 plus 0 times negative 1, which is 0. 2 times 4 is 8, plus 0. So we got a negative 4, got a 0, and an 8. So there's our product, AB. So we're not multiplying corresponding entries. It's different than sum and difference, right? When we're doing multiplication, we multiply row by column. But you got to make sure the columns from your first matrix equal the rows from your second. If not, the product is undefined and you can stop. Now, I mentioned earlier we would try to show one on our calculator. So let's see if we can get our calculator to work this time. Maybe I can show you one. So let's see about AB. So we can go back to our matrix menu. So remember the second button and the inverse key. And then highlight Edit at the top. And I'm going to store I'm going to let that first matrix, we called it A, put it in A. Now right now I have a 1 row by 1 column matrix, 1 by 1. So we need to change that, right, to a 2. So go ahead and put in there the size. So we'll go ahead and write in the size of the matrix. So you'll build it in. You got the number of row, which is 2, by the number of columns, which is also 2. So you'll build in that 2 by 2 matrix. All right, so there it is, 2 by 2. And row 1 entries, we got 1, we got 5, you can hit the enter button to move along, 2 and 0. So 1 and 5 and 2 and 0. And it tells you where you are down at the bottom left corner of row 2, column 1. It'll tell you 2, 1 on yours, mine said 1, 1. But again, I'm back at that first entry. All right. So with that said, there's matrix A at 2 by 2. Now let's go back into our matrix menu, back over to edit, and let's store in B the 2 by 3 matrix. So 2 rows with 3 columns. All right, and then we'll type in those entries, which we had a -2, we had a 0, we had a 4, we had a 1, a -1, and a 3. And we're done. Double check them, make sure your entries are like you want them, they look correct, go back to your home screen. Second mode. And now you call your matrix. So let's find the product. So back into names, you can see them stored in A and B, the sizes. So we want A, and we'll multiply that with B. So let's go back and call B. And there it is. 3, -5, 19, -4, 0, and 8, which is our result. Now again, it makes them all easy, right? You can store them in your calculator and do any of them. Sum, difference, product, scalar product, whatever you got. Now I want to move on. I want to show you another example. All right, say I wanted to find the product BC. All right, let's find BC together. So BC, we're going to be taking a 2 by 3 matrix. We got -2, 0, 4, 1, -1, and 3. And multiply it with matrix C, which is a 3 by 2. 0, -3, 1, 2, -2, and 3. Now compare the orders. So 2 rows with 3 columns for matrix B, 3 rows and 2 columns of matrix C. Now what's the same? What needs to be the same are those. They're equal, we're good, we can move on. So just make sure they are the same, because if they're not, the product is undefined. Now the product matrix, we know the result, right, of these other numbers. So we're going to have a 2 by 2 order in our product. So let's go ahead and build that. So we're going to have a 2 row, 2 column matrix. So let's go ahead. I'm going to equal a 2 by 2 matrix. So we'll build our matrix big enough for 2 rows and 2 columns. And let's go ahead and start finding the entries. So let's go ahead and find row 1, column 1, entry. So we'll take those row 1 numbers, right? We'll multiply with the column 1 numbers for row 1, column 1. So I got -2, so the first entry's -2 times 0. As we move, we add, plus the second entries, we got a 0 and a 1, plus the third and last entries, we got a 4 and -2. There's row 1 with column 1. And now let's move on to our next entry, which would be row 1, column 2 in this 2 by 2 matrix. So now we're going to take -2, 0, and 4 and multiply with -3, 2, and 3. So let's go ahead and do that. So we got -2 times -3, the first entries, plus 0 times 2, the second entries, plus 4 times 3, third entries. And that's it. That's the end, right, of row 1. And now let's move on to row 2. So now we got to take and find row 2 entries. So we'll need row 2, let's start bottom left corner, times column 1. So we're going to circle these entries. So I got to take the 1, the -1, and the 3, and multiply with 0, 1, and -2. So 1 times 0 plus -1 times 1 plus 3 times -2. All right. So 3 times -2. All right, so there's again row 2 entries with column 1 entries. And moving on, let's go to row 2, column 2. Our last entry, the bottom right corner of this 2x2 square matrix. So as we multiply those entries together, we'll go ahead and circle them. We got 1, -1, and 3 to multiply with -3, 2, and 3. So the first entries, 1 times -3, plus the second entries, -1 times 2, plus the third and final entries, 3 times 3. And there's our work. So we've done our algebra. Now let's write down our product. So in our 2x2 square matrix, a -2 times 0 is 0, plus 0 times 1 is 0, plus 4 times -2 is -8. -2 times -3 is 6. 0 times 2 is 0. 4 times 3 is 12. In row 1, simplify now. Row 2 entries, 1 times 0 is 0. -1 times 1 is -1. 3 times -2 is -6. Row 2, column 2. 1 times -3 is -3. -1 times 2 is -2. 3 times 3 is 9. So in the end, I got 0 plus 0 plus -8, which is -8. 6 plus 0 plus 12, that's 18. 0 plus -1 plus -6, -7. -3 plus -2, -5, plus 9 is 4. So there's our product, BC. You can check it, right? Put it in your calculator, double check it. Now I want to go on to one more. I want to notice the last example. So I also said find AB, BC, and find the product AC. All right. Now in the product AC, remember now A was our 2x2 matrix. 1, 5, 2, and 0. Let's write that down. And multiply matrix C, which was the matrix just using our last one, the 3x2 matrix. Right? Let's put in those entries. So we got 0 and -3, 1 and 2, -2 and 3. Now I want you to compare the sizes on these. 2x2 with 3x2. Columns from the first, rows from the second are different. They are not the same. You will not have corresponding entries if you to multiply your rows and column. So if they're not equal, there is no product, right? It's undefined. And you can put it in your calculator, and they'll tell you there's an error. So a dimension mismatch. You won't be able to produce a result. So just make sure the columns from your first matrix equal the rows from your second. And then you start multiplying rows with columns. So that's how you do matrix multiplication. So that finishes off our operations here in section 9.4.